Alright, welcome Algebra 2. This is section 1-4, solving equations. Essential question is, why is it important to do the same operation at both sides? And let's begin. So to find solutions for equations, we have to perform the operation on both sides to make it work, just to keep it balanced. So some operations you might subtract, you might add to both sides, divide, multiply. You might take both sides to exponential powers or square root them. You can also rearrange one side of an equation by using distributive property, commutative property, combining like terms. Sometimes multiplying by 1, usually you do that when you want to combine fractions. You got to have the same denominator. So these are operations you can use. As a general rule, usually you can rearrange whenever you want, and usually sometimes do it at the start, sometimes do it in the middle or towards the end. But when you're following the other rest of this order, usually you want to do subtract and add first, then multiply, divide, and then taking things to a power or square root. It's not always the case, but it's usually the case. So if you're kind of confused of what you should try to do first, try to follow that order. So let's take a few examples. So for a really basic one, what's the solution of this? The goal for all this, and even going back to this slide, the goal for this is to isolate the variable. So you want to isolate the variable. And whenever you have x equals something, or whatever the variable is, y equals something, you're done. You got your answer. So I want to get x by itself. The first thing I'm going to do is, add or subtract. Since this is plus 4, I'm going to subtract 4. Subtract 4 to both sides of the equation. Make sure you use the equal side as the divider. So subtracting 4, and when you're doing this, write down what you did. So you subtract 4 to both sides, just so you can keep track. So the 4's cancel out. Cancel. You're going to get x equals negative 12 minus 4 is going to be negative 16, and that's your answer. That was simple. Let's try a little bit more difficult. So the first thing I want to do, I have this parentheses, 3 times a quantity here. I want to distribute that 3 first. So distributing that 3, that's going to get 3y minus 9. This is negative 27 plus 6y. And I'm going to distribute. So you're distributing that 3 first. Now my next step, let's see. I have 2 y's. I only want 1 y, so I'm going to subtract one of those y's. I'll get rid of the 3y because it's smaller. You can choose to get rid of the 6y. It'll both work. So you subtract that 3y on both sides. It cancels out on the right. You get negative 9 equals negative 27. Let's see, 6 minus 3 is positive 3, so 3y. So what do? We subtracted 3y. Next thing, to get y by itself, add or subtract, I want to add. So adding 27 to both sides. This is still getting things out of y. So adding 27, let's see, and we added 27. That's going to cancel out the 27s. You get 3y equals negative 9 plus 27 is 18. And my last step here, no more adding and subtracting, but I can multiply and divide. To isolate the y, I divide by 3 on both sides of the equation. So we divide by 3. So the 3's cancel out, and I'm left with y equals 18 divided by 3, which is 6. So y equals 6. That's my solution. All right, here's a word problem. So we got to write the equation first before we start solving it. But the perimeter of the carpet is 200 meters. What are the dimensions? We got to find the length, and we got to find the width. So there's not a lot of information in the word part, but if you look at the picture, I'll notice 2 dimensions here. I'm going to call this the width right here, and that width equals x. It's labeled for x right there. And the length is going to be 3x, because it says that right there on the picture. So I'm going to write that information down. And I got to find the perimeter. I know the perimeter, this is a rectangular carpet, it's adding up all the sides. So the perimeter, P equals 200 equals each of these sides. If I know this side's 3x, then the side on the left is also 3x. And the side at the back is going to be x because the width was x. So adding all those up, I'm going to get 3x plus another 3x plus another x. Now I have to solve for x first. So first thing I can do is combine like terms. These are all like terms here. So how many x's do I have? Those are 1 x's. So that's going to add up to 8x equals 200. Now, I can't add or subtract anymore, but I can divide because I have this multiply times x. So I'm going to divide by 8 on both sides of the equation. So and then what's going to happen is you can get x equals 200 divided by 8. That's going to be 25. So my x equals 25, but I'm not done because I actually have to find the dimensions. So if x is 25, my width is x is going to be 25. 25 what? Looking at the units, it's in meters. So meters, I can just do an m. 25 meters. The length is 3 times x. 3 times 25 will be 75. So 75 meters. Those are my answers. All right, so other things about solving equations. So sometimes we have the solutions, but we don't always just have one nice solution. An equation might always, sometimes, or never be true. So it's sometimes true when usually when there's only one solution, or sometimes there's a few solutions. But in our case, when there's only one solution. It's always true when all values for the variable work, and it's never true when no values work for the variable. The way I like saying this is when you simplify for an always equation, it comes down to something that makes sense. And for nevers, it doesn't make sense. Here's an example. I'll show you what I mean. So if I take this equation right here, 4x plus 5 equals 4x plus 5. If I don't like x's on both sides, so I subtract 4x on both sides, what happens is those both cancel out. I'm just left with 5 equals 5. There's no more variables, but does 5 equal 5? Yes. So this is going to be always true. Now going to the never side, it doesn't make sense because I have x's on both sides. If I subtract 3x on both sides, well, those x's are going to cancel. I'm left with 4 equals 5. Just 4 doesn't equal 5. So this does not make sense. And so this is going to be never. So that's what I mean. I think whenever you simplify and the variables go away, if it always makes sense, if it's something, a number equals that same number, that's always. If the number equals a different number, that's never. Because that's just not true. All right. So sometimes we want to rearrange equations to solve for the different variable. So in this case, I have an equation c equals a formula right here. So it's c with respect to f. I want to rearrange this so it's f equals something. So we follow the same process. We're just trying to isolate the f. There's going to be a variable in here, but that's okay. So it's the same idea. So the first thing I want to do, maybe you choose distribute here, but you know what? I would just like to get rid of this fraction. So I'm going to multiply both sides of the equation by the inverse, which is going to be 9/5. Both sides. And when you multiply the inverse, the 9 and the 5, these are going to cancel out. So I'm going to multiply by 9/5. And I'm left with f minus 32 on the right. And on the left, it's 9/5 c. I'm going to call it 9/5 c. And I want to get f by itself. Well, it's a minus 32. So I can add 32 to both sides. And those will cancel. Adding 32. And these will cancel on the right, so I get f. On the left, be careful. These aren't like terms. 32 and 9/5 c are not like terms. They just can't be combined. We write them separately. So it's 9/5 c plus 32. So this is my equation. If you want to, you can write the f in front. So f equals 9/5 c plus 32. Either way. All right, moving on. So let's do some examples. So pause the video. All right, let's try this. Rearrange so the equation solves for c in terms of k. So it's solving for k in terms of c. We just got to flip this. So to isolate c plus 273, I'm going to subtract 273 from both sides. Write down what I'm doing. Subtract 273. Once you do that, those cancel on both sides of the equation. And what I'll get is I'll get c equals k minus 273. And there's my equation. If I want to, I can write it as c equals k minus 273. Either way, move on. So pause the video. And the solution. So I check my order. Do I want to add and subtract? Well, there's no adding and subtracting. So multiply or divide. Well, to isolate the b, I want to divide by 12 on both sides. So you do that, cancels the 12s, you get b equals 18 twelfths, but we always want to reduce that. We don't want to leave it as 18 twelfths. And 18 over 12 can be divided, top and bottom, by 6. So what you're left with is 18 divided by 6 is 3, 12 divided by 6 is 2. So your b equals 3 halves. If you can rewrite that as 1 and 1/2 if you wanted to, but I'd just like to keep it as an improper fraction. Just leave it like this. Don't bother with the mixed numbers. It's good to know that though, but you don't have to right now. Try the last example. 3, 2, 1. Okay, so solving for this. So the first thing, I don't like these parentheses. I'm going to distribute both the 3 and the negative 2. Very careful when you distribute that negative 2. So 3 times 2 is 6x minus 3. Now you're distributing this negative 2, not just positive 2. So it becomes negative 6x. Negative 2 times 4 is negative 8 equals 11x. Combining like terms. So I distributed. Combining like terms, 6x and negative 6x will just combine to 0x, so those cancel out. And then negative 3 minus 8 is negative 11 equals 11x. We combine like terms. And my last step is to isolate that x, since it's 11 times x, so divide by 11 on both sides of the equation. Those 11s cancel, so I divide by 11. And I get x equals negative 11, so it'll be negative 1. So that's my solution. We're done.